Hi, everybody. Thanks for coming to our talk. My name's Norm Johansson, and with me is Steve Roberts. We are both software developers at Amazon Web Services, where we focus on the .NET tooling. That is the AWS SDK for .NET, the AWS Toolkit for Visual Studio, and the AWS tools for Windows PowerShell. Today, what we're going to learn about is how to do ASP.NET 5 development with AWS. ASP.NET 5 is the new redesign of ASP.NET, which is currently under development as an open source project out there on GitHub. Some of the major goals of this redesign is to make ASP.NET 5 modularized and cross-platform. So Linux and Macs will be first-class platforms for development and deployment. Once we go over some of the development aspects, we're going to talk about how we can actually deploy ASP.NET 5 applications to AWS today, even while it's in its beta stage. First, we're going to take a look at how we can deploy it using AWS CodeDeploy. And here we're going to still use a lot of the things we're familiar with. We're still going to deploy to Windows, still take advantage of IIS. So we'll use things that we're familiar with, but use the latest and greatest ASP.NET 5. And then we're going to take advantage of the cross-platform support and use Docker as a deployment mechanism, where we can make our application containerized, and we're going to run it on Linux. And AWS has a couple services that can actually deploy Docker for us. We've got AWS Elastic Beanstalk and Amazon EC2 Container Service. And we're going to take a look at both those services today. Before we get into that, I want to give a quick update on the AWS SDK for .NET. We released version 3 of the SDK last July. And this is our new fully modularized version of the SDK, where every one of the AWS services is a separate NuGet package with a dependency on a common core runtime. And we did this modularization for a couple reasons. It let you, as developers, be able only to include just the parts of AWS you want in your application, giving you a much smaller footprint for AWS. And it helped us out, too, because as you see in the keynote, and you follow our blogs, you see there's new AWS services updates going out all the time. So our SDK was getting updated on a weekly, if not more frequent basis. So now you only need to take updates for when the services your application are using are getting updates. Included in every one of these new V3 NuGet packages is Xamarin support. So now you can use the SDK to do iOS and Android development as well. We designed version 3 of the SDK to have a high compatibility with version 2. Our hope is that most customers will only have to go and remove the NuGet package to the old AWS SDK package, and then include the NuGet packages for the services they're actually using. So what is ASP.NET 5? I mentioned it's open source out there on GitHub. It's going cross-platform, and they've modularized ASP.NET. And one of the reasons they did this is that you can actually now choose which part of ASP.NET you want to use. For example, if you're writing a microservice that is only using just the web API, you can remove components, like you don't need the static files module. And this can actually give you a smaller footprint and give you better performance, because there's less modules in the pipeline. Now, ASP.NET 5 works on .NET 4.5.2 and above, Mono, and the new CoreCLR runtime. And that CoreCLR runtime is the new cross-platform runtime, which has a new modularized .NET framework. So now we have our modularized AWS SDK for .NET. We have our modularized ASP.NET 5 framework and our modularized .NET framework. So now we can have a really refined set of exactly what our application needs, giving us a much smaller application. For development, we have a new project structure. So the role of the Visual Studio project is greatly diminished. There's now this new project JSON file, a JSON file that defines all of your dependencies, as well as how do you actually build and run your application. And we'll take a look at more at that later. We also have a new suite of command line tools. The first one is DNVM. That VM stands for Version Manager. This is how we get to include the runtime we want to use with our application. And this is a new thing for us, where we actually get to decide on a per application which .NET runtime we want to use. So this saves a lot of IT's fears of when the developer says, I need the latest version of .NET on the server, and you don't know how that's going to affect the other applications running on that server. In this world, that runtime is bundled with the application, so it's only going to affect just that application. Then there's D and U, the U being utility. This is a command line to help you manage your NuGet packages, easily restore all your packages for a project. And it also has utilities to be able to package up your application and get it ready for publishing. And then DNX, this is the new execution engine. This is what's actually going to run your application now. In the ASP NET 5 world, you're not really creating executables like we're used to. You're actually running your application with the source, actually, with DNX, which is going to build and run your application on the fly. ASP NET 5 is currently on beta 7. I think beta 8 is imminent, like maybe next week on the Microsoft roadmap. They've listed November as the when RC for ASP NET will come out. And Microsoft's goal is for the 1.0 release to be Q1 next year. The way we are supporting ASP NET 5 in the SDK is we've released a new version of the SDK, the 3.2 beta version. So that's the one that's got all of the CoreCLR support. So if you still need the current stable version, all the latest service updates, we're going to keep maintaining the 3.1 version of the SDK while ASP NET 5 is under beta. Once that's out of beta, we'll take our 3.2 out of beta, and then that will become our new current stable line. If your application is coding that new CoreCLR runtime, that cross-platform runtime, there are a couple coding differences you need to be aware of. The first is all of your AWS service calls only support the asynchronous pattern. And this is because the HTTP client that we have available to us under CoreCLR only has those calls, the async calls. And if you're writing your server, your ASP NET server application, you're wanting high scalability, using that asynchronous pattern is your best practices. Because otherwise, you're going to have a lot of tasks and threads being blocked waiting from responses on servers. And in this case, those tasks can be doing something more useful. Credentials management has had a slight change as well. If you've been using our SDK before, you've hopefully seen we have that embedded encrypted SDK credential store. That is not currently supported in the CoreCLR version. The reason is because the way that works is it's actually doing some p-invoke methods to some Windows API calls. And since we're cross-platform, that isn't necessarily available to us. We're still looking into this. I'm kind of hoping we can at least make it work for when we're running CoreCLR on Windows. So look for updates on this, but that's where we are today. So alternatives is you can use the shared credentials file. This is the text file that lives under your users directory. And this is supported by all the AWS SDKs and tools. You can also use environment variables as well. And then when you're actually deploying your application, you would want to use IAM roles to get your credentials to your application. So when we started looking at how can we support ASP NET 5 with the SDK, we thought we should actually start writing an application and see what that's like. You want to show it off, Steve?
Sure. So what we've got for you is an application called Polister. And if I just go away to a tab here and look at Polister here, Polister is an app that serves polls at scheduled intervals. So as a user, you can go in and you can create a poll, give the poll options, schedule when you want it to start, when you want it to end, et cetera. And then at the relevant time, the poll will become visible on the screen. You can see a number of polls here. Back in Seattle, the team got their heads together and like, what can we show for polls? And we thought, well, it'd be really useful if we could try and get some feedback of where do you want us to go next with the SDK for .NET and the tooling, right? So we put some polls together. So we invite you to join in. You can go to www.cloud-polster.com. Please vote. There's no guarantees we'll do it. Let's be honest here, right? But it will guide us a little bit in where we go in the future. Now, full disclaimer, we don't want total chaos today. So we've disabled the ability to create polls. Okay, so that won't work. You'll get an error if you go there. But please go to Cloud Polster, do some polling, and let's see. Oh, I know that I'm voting on this, so there we go. And we go,
that got
it's popular
fast.
already. Yeah, yeah. So that's Polster.
No one said no on that. So here's the 10,000-foot architecture view of Polister, right? We have ASP NET 5 MVC application as our front end, which communicates to a collection of microservices in the back, which are dealing with specific tasks like getting the actual current polls, processing the votes, and creating the new polls. And we chose this microservices design because Steve likes to put bugs in my code. And when we fix those bugs, we want to just deploy the service that's effective. So if there's a bug in the poll feed, then we want to deploy just that one. Then we also have this ASP NET 5 console application. And this might seem a little strange to think of ASP NET having a console application. But what this means is this is a program that still has a main function, but it's run by that DNX execution engine. So we're not creating an executable. We are giving that source to DNX, and DNX is going to build it and run it on the fly, and that's going to make it cross-platform for us. So services Polister use is we use Amazon DynaDB to actually store the polls. As we saw, the polls have a time when they go active and when they get expired, so that scheduling is all handled with simple workflow. And then we use simple notification service to actually send out the results of that poll. And to help us with all the debugging, we pushed all of our log messages out to CloudWatch Log so we could see what's going on without having to try to log onto the machines. So let's take a look at the source.
OK. So in Visual Studio here, we've got the Polister solution. And we've basically got 6 projects of interest. We've got some common code. And then we've got a project for each of the little microservices. And then we've got the Pol Web front end, which is the MVC app. And if I open that up, if you haven't seen ASP .NET 5's project yet, it looks very similar, right? We have our models, we have our controls, we have our views. We have some static content here on a www root that we'll come to later. And then if we scroll down, we see we have a project.json file, which we'll come to again shortly. Now, as an IIS kind of deployment guy, I'm kind of looking for web config, but I'm not seeing it here, right? I'm seeing some config JSON files.
Right, that's one of the things they've changed at ASP NET 5 is they've gone away from the whole having the web config file and made config a lot more configurable. You can have JSON config files or XML config files or INI config files or environment variables. You get to control a lot more of that, which is where we're using JSON config files. And another concept that's common throughout ASP NET 5 is this environment variable, ASP NET env. It's describing the environment that we are actually running our application at. So here in Visual Studio, we're basically setting the environment variable to development. And then when we run our application, we're using that environment variable to let us know which one of our configs do we actually load up. Do we want to load up the development config or our CodeDeploy config or Beanstalk one? We have all those controls. And that config is what we are using in Polister is how do we actually find our microservices.
So in a sense, this is like the web config transform that we had before where it was just debug or release. This kind of similar system, right?
Often it's that environment was also used for to determine whether do I want to use debug JavaScript or minify JavaScript. So we just kind of used it also to decide our config file.
OK, so that's our project, not much different.
So once, we forgot to mention too, we actually open sourced all this code. I skipped that step. So we don't have time to go through a lot of the code. Actually, that's all we really have time for. So if you want to see how we developed that application, all the thing is put out in our samples GitHub repository. We went past that link, but it's also at the end. So anyone wants to see how we developed that, it's there. So once we had that development, we wanted to figure out how we actually deploy this currently to AWS. And so the things we needed to think about is how do we actually package up our application, which for that we got for free, because that DNU command actually has the command to package up all of our stuff for us. And then what environment we deploy to, we need to make sure it actually supports ASP.NET 5. Because ASP.NET 5 is brand new, and it's getting new updates all the time, and our Windows AMIs are not going to have it on there. So how do we make sure that it's going to be there? And that's where we're going to take advantage of the fact that we can bundle our runtime with our application. In Polister, we have 5 separate processes to get it all up and running. So how do we actually ship all 5 services to our environments and get them running? And ideally, we want to be able to deploy each one of those independently. We don't want to think about, we have a bug fix in one service, how do we now have to deploy the whole entire system? And once we get it deployed, how do we scale this thing? What's our strategy? The first thing we're going to take a look at is how did we deploy our application to AWS CodeDeploy? And again, we're going to stick here with Windows and IIS, the things that we're familiar with. And our Windows AMIs do not have ASP.NET 5 on there. So we're going to bundle our runtime, our .NET runtime, with our application. And that's how we can get it to run there. And CodeDeploy allows us to have a very scriptable deployment mechanism. We can actually use PowerShell and batch files to do any sort of setup we need when we deploy that. So our primitives for AWS CodeDeploy is we have an application. And this is that logical container of our application. And it has a deployment group associated with it. And that deployment group shows all the EC2 instances that I actually want to deploy this application to. And we can actually reuse those same EC2 instances for multiple deployment groups. Steve, actually, why don't we take a look at how we set that up for us?
Sure. So I head off to the console, and in here, go to CodeDeploy. And then here you can see, here's all our applications. Click on one here. Here's our deployment group. There's 2 instances running each of the services.
Right. So we had every one of our 5 separate processes is considered a code deploy application. So we're basically going to deploy each one of those independently. And so our deployments is an application bundle, within this case a runtime as well. And it also has this app spec YAML file. This is the file that tells CodeDeploy how do I actually install this application. Here's what the app spec file looks like for our pull feed service. And this one's pretty basic. All it's really doing is extracting all our files underneath IIS. And then during application start, we run a PowerShell script that sets up that virtual directory in IIS. And then on application stop, essentially when it's being uninstalled, we run another PowerShell script to remove it so we can clean up after ourselves. AWS CodeDeploy is considered one of our building block services. You get to decide what is your compute architecture. You're going to set it up. So we could do something very simple, like create a load balancer and a few EC2 instances, and create a deployment group for that, and have all of our Polister services running on each of those machines. Alternatively, we could say some of these services are more high traffic. So let's put those on a deployment group that's got more compute power behind it, and put our lower traffics on a smaller deployment group. So there it just sort of depends on what is your needs. You get to define that compute architecture for you. So we've actually already deployed it, as you saw. So let's take a look at how we deployed it. And Steve, I noticed when we did look at Poster, the banner was wrong, right? It said development, didn't it?
That's right, yeah. So at the top here, we've got a little banner that just tells us what that ASP NET environment variable was set to. And obviously, you didn't pick up my code change.
You probably didn't check it in right.
So let's fix that, and let's redeploy it. So go off, get rid of the config file, take that out. So I happen to know that's in layout, and I think you were a bit upset when I put this in, so you commented everything out. So let me just swipe and uncomment all of this. And edit. Uncomment. OK. That's the only change we need to make, right? We're not deploying binaries anymore. We're deploying source code with ASP .NET 5. So we're good to go.
All right.
So is this the point at which I get to run that new DNU command you mentioned to do publish and
We could run the
package?
DNU now to actually start packaging up. What we thought when we started looking at this is we really wanted to centralize how we do everything. When you use DNX to actually run your application. And you actually get to write your own custom commands as well. And so we thought if we wrote deployment commands, that would be part of our project. And since they're DNX console applications, it makes those cross-platform. So if we look at our project JSON file, we can look how we set that up.
So here's the JSON file. So you can see our dependencies, our references effectively. If I scroll down, you can see a bunch of commands, Kestrel, and then some custom commands.
Yeah, so those commands is what DNX uses to figure out how to run your application. So Kestrel is this web server you can use to self-host your ASP NET applications. And the bottom 3 are the ones that we wrote, which are basically going to run that command line, Polister deployment commands, which is a console application. So we have one of those called deploy CodeDeploy. Why don't we just go ahead and run that first?
So I'll just jump away to a console. Hopefully you guys can see this. Yeah. So I'm just going to run DNX and then deploy -CodeDeploy. Run. There we go. So it's off and running. So should we go take a look what that's doing?
Yeah.
So down in our solution file here, we've got a tools folder. And here's a project that corresponds, if you see, Polister deployment commands. It's just a simple console application, but in there, we have CodeDeploy processor. And if I scroll through this code and get down here a little bit, you'll see here's the execution. So we get the publish directory where we're going to put the bundle to as a zip file. And then we're calling something called execute publish. So if I just navigate away to that, you'll see here all that we're actually doing is getting an output folder, packaging all the files together. So this is effectively wrapping DNU, right? Because you've got a runtime switch as well.
Right, yeah. Like I said, we could have run just DNU. We decided to wrap it around so we could always have a consistent set of arguments. It was just part of our project setup. And we have that extra boolean there to say to include runtime. And so that's how you can see, as part of the command line argument, we're saying include the current active runtime that's running on my box.
OK, so let's run DNU. So we have the application package ready to go. So we go back to the CodeDeploy processor. We then, looks like we're doing some copying of files. We're copying the AppSpec YAML file to the root.
Right, because in our source code, we have that AppSpec file kind of buried in one of our folders with all of the rest of our CodeDeploy information. And CodeDeploy expects that AppSpec YAML file to be at the root of your application bundle. So we just needed to move that up to the top of the bundle.
Okay, so once that's done, we then zip up the directory where we've bundled everything together. And then this looks familiar. We just create an S3 object, upload the bundle to S3. And then we send a create deployment request to CodeDeploy with a new revision location pointing at the new bundle in S3. It's as simple as that, right?
Yeah.
Probably been done. Let's go check. There we go, deployment initiated. So if we now go to the console, go to CodeDeploy, and then go to the top and select deployments, we should see one of the last few seconds. Oh, it says a minute ago. There we go. CodeDeploy, looks like they've all gone through. Yeah, 2 instances done. So if we now go and launch a window, if we now go and launch a tab onto that version of CodeDeploy, Polister on CodeDeploy, we should hopefully see the banner has changed. Of course, there's a few seconds because we're deploying source code, so in-memory compilation is going on now. There we go. We're in page serve from Windows IIS and AWS CodeDeploy.
All right.
Fixed.
There we go. So that's how we were able to.
All right. So I'm going to vote again. Let's see how we're doing.
I'm sure everyone's voting for that. That was the give me.
He's thinking about it.
Yeah, no, it's compiling that source too.
Ah, whatever. Oh, 79. Very interested. OK. All right. So to the slides.
What'd you learn, Steve?
So I learned, well, right now I'm feeling super comfortable, right? Because I know IIS deployment. I know that I can now take advantage of ASP .NET 5 and take just a bare bones instance and deploy my app, right? I don't have to wait for somebody to set up a custom army for me with the runtime, et cetera, that I need. I can do traditional .NET. I can do CoreCLR if I want. We can still deploy each service independently. I only sent out the web front end there. I didn't send out all of the individual services. And scaling's pretty simple, right? I just add new instances, right? It's as easy as that. So yeah, it's pretty cool.
So now, Steve, let's challenge you here a bit. Let's go to Docker now, where we're going to actually containerize our application, where we're going to take each of those 5 Polister services and run those as separate Docker containers. In this way, they're going to run in complete isolation, giving us control of how much CPU and how much memory each one of those containers is going to use. And remember, Docker currently only runs on Linux. We know Microsoft is working on making Windows-based Docker containers, so next year we could have a different conversation, but today we're going to take advantage of our cross-platform support. So a crash course for you, Steve.
Yeah, I know nothing.
We're going to learn about, so Docker has images, and an image is basically a snapshot of your application. It contains all the files and all the dependencies for your application, along with the instructions on how to actually start your application up. And then there's a container, which is the running instance of that image. It's very similar to a virtual machine, except it's a lot more efficient because it reuses a lot of the host machine's resources. You only get your own separate copy of those resources once you try to change them in the container. And this gives us a big performance benefit, as well as the near instant startup for these containers, versus a virtual machine, which can take several seconds or minutes to start up. And then once we've run our container locally, we've proved that this is the perfect container and it's awesome. We wanted to share it out to other machines running Docker. We can push this image to what's called a registry. And then other machines that are running Docker can actually pull those down and start running it. And registries are either public, like the official Docker Hub registry, or they can also be private as well. A little bit more on images. Images are actually all built on layers. So when Steve and I are working on containerizing our services, we're actually only defining really that top layer, that Polister service layer, all the files that we care about. But then we say this layer depends on another Docker image. In this case, we want to depend on the ASP NET 5 Docker image. This is the image that Microsoft maintains. And then that one says it has a dependency on mono, and that's how we get our runtime. So in this case, our runtime isn't bundled with our application. It's going to be already be part of our Docker container based off of our layers, which then also the mono has a dependency on Linux. So that's where we get our full stack. To create a Docker image, we write what's called a Docker file. That defines all the files we want to include in our image. We also say what ports we want to expose from our container out to our host machine, and then whatever instructions it takes to actually start our application up. Once we have that file, we use the Docker command line to actually do that build. You feeling brave, Steve?
Let's give it a go.
All right. Sweaty hands?
Yeah, sweaty hands. It's console work, right?
Okay.
OK, so I noticed that in the project we had a Docker file. So let's go and take a quick look at that. And OK, well, I was kind of expecting something a little bit more detailed, to be honest, right? But based on what you just said, I'm going to have a crack at decoding this, right? So you said that we only have to declare the layer that we depend on immediately below us, right? So that's the first line, the from. We don't need to worry about all the other bits underneath. We're building an image in this particular case, so add just suggests we're adding everything in a certain folder to a /app path in the image, right, of the workdir set. Expose 5000, you were talking about ports, right? But my users are not going to expect to go to port 5000.
Right, so this is going to be the port that the container exposes to the host. But then we can actually set up Docker. We can map our host ports to our container ports. So that's when we're going to later map port 80 on the host to map port 5000 on our container.
OK, an entry point Kestrel, I guess, is just the web tech that we're going to host in. OK, so there's our Docker file. So I guess we go back to the source file, the source folder, and you want me to write some Docker code here, right?
Well, first we got to publish our application. And then we could use DNU publish, but we also created one of our DNX commands, publish only, which encapsulated that DNU.
That was the bit that wrapped DNU, right?
Yep.
OK, so DNX publish only.
So what really this is doing, it's doing DNU. We're also copying everything to our temp folder. We have found in our experience that a lot of these NuGet packages create some very long names, and we very often run into the Windows 260-character file path limit, which drives us all crazy. So I pushed everything to the temp folder.
OK, that's done.
Why don't we go look at the temp folder and see what it did?
OK. So Pol web front end, here we are. So here's www. That's the static content we saw in the project. We obviously have some scripts lying in here, but we've got this new thing called app root. Packages, I guess, is all the packages it's sucked in. If we go into source, there's our application packaged up effectively, ready to go. Yep. All right? So all is good. So back to the command line.
So now we need to go on our console that's actually in our published folder, and we actually want to run Docker build for that.
OK, so here we are, Pol web front end. So Docker, and you said build.
Yep. And then we need to tag our new image.
This is like a version, right?
Yeah, like a version.
OK.
So we do a -t to say we want to tag it. And then when you're pushing Docker images to Docker Hub, you need to give it the namespace. For us, our namespace is AWS.NET. And then we need to do a / and the name of our actual image. And all of the mechanisms that we created for Polister for deployment is doing all the name heuristics based off of our project name. So we need to name our image the same as our project name.
Is this case sensitive?
Yes, Docker actually requires all the names to be completely lowercase.
OK. OK.
And then we do colon, and you get to pick a tag. What do you want to call it?
Let's use the session ID. So DEV302, I think it is. OK.
OK. Now we need to point to where our Docker file is, and that's with the -f command.
OK. And that will be the Docker file that we deployed out to app root in that package, right?
Right.
So that's going to be, let's see, I'm in there. So it's going to be /app root. Source, Pol web front end. It should be Docker file. There we go.
Right.
Yeah.
And then we just need to say we want to run from this directory. So we'll include everything from this point down. So this should very fast.
Done.
The reason this is fast for us is we've already ran this before, and we've actually already pulled down that base image, that Microsoft ASP NET layer. If we were running for the first time, then it would have to pull that layer down. So now, ideally, what we would do is we would now do Docker run to actually start running our application. We're going to assume for today's sake that Steve wrote the most beautiful code and it's ready to ship. So what we do then is we actually push it to our registry. And we do that with Docker push. And we give the full name to our image that we just created.
We do?
Yeah, AWS.NET.
Oh, the tag you mean? I'm sorry, I thought you meant the folder location.
Oh, no. Sorry.
Front end colon dev302. OK, I believe that's what I typed.
OK. And we've actually already, so this is going to be pushed to Docker Hub. And we actually ran Docker logon previously today to handle the logon, which is why we were able to do that without it being prompted. This takes a little bit to run, so why don't we go back to the slides while that's pushing up to Docker Hub. So we've seen how you can now create this image with AWS and AWS SDK and ASP NET 5 code. Now we're going to start looking at how we can actually deploy this Docker image with AWS Elastic Beanstalk. And Beanstalk has a couple ways you can do this. They have what's called the single container environment, which is for when you have your monolithic application that's all in one image. But that's not going to work for us because Polister, again, it's got 5 services that we want to deploy each independently. So they also have what's called the multi-container environment, which actually is a wrapper around the EC2 container service, but it simplifies a lot of the administration. We don't have to think about our compute architecture, how we create it. It'll create it for us, but give us a lot of power to still how we want to tweak it after it sets that up for us. So our primitives for Beanstalk is we have an application. This is our logical container for the application. And then an application version, which is a pointer to our application bundle in AS3. And then we have an environment, which is the actual AWS resources that's going to run our application. And I mentioned, unlike CodeDeploy, which was a building block service and we had to create our compute architecture for us, Beanstalk is going to actually create this compute architecture for us. We say create the environment for us. It's going to set up the load balancer and auto-scaling group and create up the EC2 instances all for us. And once it has that, there are also a lot of extra knobs we can then tweak on that to customize it for us. So it's got a lot of power in just getting things up and running. Now, to deploy our application to Beanstalk, we have to write what's called the docker run.aws.json file. And this defines, or this is actually the application bundle in this case. So this is very different than we're used to with our traditional Visual Studio deployment, where essentially we right-clicked it in Visual Studio and we said publish. That compiled it, zipped it up into a web deploy archive, and sent it to S3. Here we have just this JSON file. The reason it's done that is because we actually already pushed our application to our registry. And what this file is saying is what images do we pull from our registry. And then it's going to say, for those images, what's the runtime configuration, any environment variables we need to set, the memory and CPU we want for that image, and the port mappings. And that's how we can say, let's have port 5000 go to port 80 on the host. So we've actually already deployed this. Steve, you want to show what it looked like in the console?
Yep. So back to the console, scroll up and go to Beanstalk. So here's our Beanstalk environment for Polister. And we just go in here, running away nicely.
OK, and then we've created a new image. So let's update our Docker run file to point to that new image.
So here's the Docker run file we're interested in. So you can see here each of the individual images or projects that we were working on. So let's change this version here to be DEV302. I can see you've got your environment variables set, you've got your port mapping set, but line 51 looks interesting. Links, what's that for?
So actually, if you look in the config file for Polister for Beanstalk, you can see the way it's actually trying to find the microservices is by the name of that service. And when we say in that Docker run file we want a link, what it's going to actually do for us is when that container is deployed, it's going to write into its host file to make the name of those images point to the containers running that IP address. So that's a way we can get that, pass that information into our master web front end, how to connect to our services. So why don't we try actually deploying that?
OK, so I've edited the Docker file, so I'm just going to upload and deploy here. So I'm going to choose the file, which is not where I wanted it to be. Where did I put that file now?
You need to go to
in samples. All right. We get to look through your machine now. This is cool.
Yeah.
All right, where did you put it? Git repros?
Yep.
All right.
Samples is down there. The bottom.
Samples is where? I'm not seeing it yet.
It's the joy of switching machines right before the talk.
There we go. Is this the one I just changed?
Yeah, reinvent.
All right.
So this is that samples repository we talked about.
Oh, that's actually quite useful that we're doing this then.
Yeah.
Remember, it's on GitHub. Right,
back up one.
Back up one, sorry. Policy.
No. There.
One more.
Deployment scripts.
Deployment scripts, of course.
Beanstalk.
Beanstalk. There we go. All right, and I'm just going to give this the same version tag. It doesn't have, it can be anything, but I'm going to use the same one. There's nothing else that I need to change there, so I'll hit deploy. OK. That's up and running.
So now Beanstalk's going to now take that file, and it's then going to find out what are the Docker images I need to pull down and start running those. we could actually go into one of those machines and check out, see what's going on.
OK. So I've got a Visual Studio. I'll open up the AWS Explorer. Quietly. Here we go. So I'll open up EC2 instances. So I'm guessing you've tagged these with, we go, Polister Beanstalk. So it's Linux, so I'm going to SSH. We used a key pair, so I'm just going to click OK. The toolkit will do all the work.
I might not have changed the fonts here.
Yeah. Oh, no, that's quite large. Maybe I should have used the machine at the top. Oh, look, can't open file. All right, let me try the other one. Yes, I do want to close the session. All right, Polister Beanstalk. Let's try that again. There we go, that's better. All right, so here I am on the machine. So how do I see what's running?
If we do a sudo docker ps, that actually tells you all the current running Docker containers.
Okay. OK, there they are. So there's our individual projects or our containers. They all restarted 12 seconds, then 24 seconds ago.
Yeah, that's one of the things you should be aware of when you're using Beanstalk as your Docker deployment. We only pushed one new image, but all of them do get restarted in this multi-container environment.
So you mentioned there was like a host remap going on with that links, right? Can I dig into it from here?
Yeah, we can actually open up a bash shell script into, when we do into the web front end.
Okay.
To do that, we do a sudo docker exec.
OK.
And then we do a -t to give us a terminal, a -i to make it interactive. And then we got to pass in the container ID, the one we want to actually connect to.
OK.
And then say we want to do a bin bash to open up a bash script. So now we have a bash script right onto that container.
OK, so just look at more, etc. Hosts. Oh, there we go. See, we poll feed, poll voter, and poll writer from the links that are in our config.
Right.
Nice. All right. So if I exit from there, we'll exit out of that shell, and we go back to our link here and bring up the Beanstalk environment. But, wrong one. Yeah, that's the right one.
That's right.
That's the right one.
We get the banner fixed.
There we go. Got the banner fixed, Docker, and Beanstalk. Yeah, cool.
Okay.
And I'm going to vote again. I know how many times I've voted, so we can discount this from the actual total. OK.
What'd you learn, Steve?
Well, it's pretty simple to set up, right? We can still push our images independently. However, when we deploy to the container, all those images, all those containers are going to restart. It's just one of the things we have. Scaling, similar to CodeDeploy, we just add another machine. But it's pretty cool. I can take an ASP.NET app and just deploy it to Beanstalk and run it on Linux.
Right.
That's cool.
So now that we've seen how to do it with Beanstalk, and I mentioned that Beanstalk multi-container is really wrapping around the EC2 container service, let's take a look at how we could use that service directly. So our primitives here is we have a task definition, which is its collection of container definitions, and we get to specify the CPU and memory and port mapping environment, very similar to what we saw with that Docker run file from Beanstalk. And then we have the service. A service is a long-lived task, like a web server or our console application that's pulling Swift. That's actually going to run our process. And this is another interesting thing about services that we haven't seen before, is we can optionally associate a load balancer with a service. So we're used to thinking of load balancers as always being tied to an EC2 instance. But in this case, it's on the service. And so ECS is going to always look at your cluster and figure out where's the best place to run all these services. And when it does that, it's going to make sure that the load balancers are up to date with where that service is running. So this is going to allow us to be able to do scaling, not at the instance level, but at the individual services level. And then we have our cluster, which is the EC2 instances that's running our tasks in service, as well as the ECS agent that's going to keep our load balancer updated and orchestrate our running of our services. So again, we've already deployed this. Let's see how we did that in the console.
Okay, so I'll go up to the console again, scroll up and go to container service. And if we drill into task definitions here, you can see here's our various tasks. Here's the one that Beanstalk created for us. And if we go in there, you can see there's all the individual task revisions that we have there. If we go back,
take a look at the task definition.
Sure, yeah.
And you can see with Beanstalk had actually created all of your services, our Polister services, under one task definition. And this is why we saw that restart of all the services, because that whole task definition gets restarted. So with Polister, you can see we actually made each one of our 5 separate services as separate task definitions, which allows us to deploy them independently, and only just those ones get restarted. So ECS is, again, like CodeDeploy, one of our building block services. You get to decide your compute architecture. It's up to you to set everything up. We could do something very simple, like let's have one ECS service that contains all of our Polister services and have that run across all of our machines.
So that would be very similar to the Beanstalk model, right?
That is very similar to how Beanstalk is doing it. We could also do something more advanced, where we then put each of our Polister services as separate ECS services. And then for all of our web processes, we could put load balancers on each of those. So this is going to allow us to do scaling at the individual services level. For our example, Polister, we know that the front end is our most important service. If that goes down, then all anyone sees when they come to our application is errors. So we wanted that to be running across all of our machines. In the other services, we could do a varying amount of instances of those services, depending on the needs of that service. Now, to deploy a new version of our application to our ECS cluster, we need to build a new image with a new tag. We need to push that image to our registry.
Which we've just done.
We've just done that. Okay. We did that for Beanstalk. Now, to do for ECS, we need to update that task definition to reference the new image. And when we do that, that's going to generate us a new revision ID for that task definition. So then we have to go to our service that's running on our cluster and say, you need to run this latest task revision. So let's go do that, Steve.
OK. So I'm guessing it's another one of your custom commands?
That is true.
OK. So we'll go to the source code. Here we go. So DNX, and what did you call this one, Norm?
This one is ECS-task-update.
ECS task update. Oh, you didn't tell me I need a tag.
Right. So here we need to say, this is the image tag that we want.
Is it the full tag that I have to type?
No, in this case, we're only going to do just DEV302, because we set up Polister so it's always using the name heuristics, knowing, hey, you're currently in the Pol web frontend, so that's the name of our image.
OK.
So we're going to kick it off. That takes a little bit to go, so why don't we go look and how that's running.
So let's scroll down through Polister here, ECS update task. So here we are in our custom command. If I scroll through, and we'll get to here, so you can see what we're doing. Let's get rid of the IntelliType. So we're fetching the task definition, and then we're getting the container definition from that. And then down at line 66, that's where we push through the new tag that we just typed in. We register that.
Yeah, so this registers a new task definition, and so we're going to get a new revision ID.
Right. And then presumably we do something with that revision ID. I'm guessing. Oh, yeah, we just, yeah, OK. So we, ooh, perform rolling service deployment. This looks interesting. I can see it right below. What's going on here, Norm?
So when we say we want to start a new task definition, what's going to happen is it's going to spin up all of the new instances, new tasks with our new task definition. And once those are all up and running, it's going to tear down the others. And that's going to give you that minimal downtime. Now, the tricky thing is, for those new instances to come up, there has to be the available resources for those to come up. There has to be the available memory, the available CPU. And what's also, in our case, there has to be the available ports for that to come up. So we have 3 machines in our cluster, and we're currently running 3 tasks. So we have no available port 80s open. Okay. So what we're doing here is essentially, let's cut in half the existing tasks running to free up some port 80s, and then start launching some of the new instances.
OK. All right. So it looks like what we're doing then is describe services. We get the number of services in total. We then chop that in half. So we're taking half of them away.
Yeah, so half the old ones go down.
Ports. Wait till that's done, because there's no point running otherwise. Then we update with a new revision. When those have come up, we then just spin out the rest. Well, yeah, very simple. Let's see if we've actually got some console output here. Oh, there we go, yeah. So starting rolling deployment, reducing the number of tasks to 1, 3 in half, 1. Okay. Starting 1 task to the new, and then the remainder coming up. So it should actually be launched now.
All right, let's go see if we've updated the banner on our main website.
So if we actually go to the real website.
Yeah, Cloud Polister is actually pointing to our ECS cluster.
Like this should update. There we go, Docker and EC2 container service.
There we go.
Done. Neat. All right, I'm going to do it again. Oh, no, it's .NET and Aurora. I'm moving away. That one. Cool. I'm interested in both, obviously, but, you know.
All right, shall we go back to the slides?
Yeah.
So what did you learn now, Steve?
So in this particular case, the redeployment only affected the task running that image, right? Because we have separate task definitions, all right? We have lots of different scaling options. Now, we're a little bit closer to the metal in some terms, right? We have more control over how compute resources are divided. Beanstalk does a lot for you. We're taking a little bit of control back when we use ECS directly. So you could say, you could argue we're trading simplicity for control. That's no bad thing. And I notice to see you're saying recommend CloudFormation for setup.
Right, and you will see if you check out our GitHub repository of Polister, you'll see all of the PowerShell scripts and CloudFormation templates we use to create our CodeDeploy and our ECS cluster. So to recap here, we learned that ASP NET 5 has a lot new deployment possibilities for us, and we covered quite a few different options for us. And I would say all these options are equally valid. It really just depends on your needs. AWS CodeDeploy, we looked at how we can still use Windows, still use IIS, but we got to use the new project structure, the new modularization of ASP NET 5. With AWS Elastic Beanstalk, it was an easy way for us to get everything set up and to start actually using Docker with our application. And then using ECS Container Service, we got full control over all of our compute architecture, and we got some new options for how we want to scale our application. So just closing here, we have some extra links for you guys to look at. The first is our GitHub repository. Actually, Steve, we have time. Why don't you click on that link?
Sure.
So this is the repository of the AWS SDK. It's very useful. If you scroll down, I mentioned everything is modularized. So down below we have the list of all the NuGet packages. So if you're ever trying to find one of the services, this is a really easy way to see what are all the services and how to get them for NuGet packages. The other link is pointing to our samples repository. Do you want to show what we got there, Steve?
Yep.
So this is where we have all of our console applications, our Xamarin, as well as we've been putting our reinvent code. This talk here, as well as Steve has a talk on PowerShell tomorrow, if you want to learn about PowerShell. So all that stuff is right there for you. And if you want to follow our blog, where Steve and I often blog about .NET development with AWS. And there's some final links on the services we use. So with that, thank you. Really appreciate you coming to our talk and filling those evaluations, as well as Cloud Polister. And do we have time for questions? I think we do.
It says we got 8 minutes.
So any questions that we can answer? We have a few minutes there.
Thanks.